Hi everyone, this is Tausif from Snigdho, lecturer, BRAC University. Hope you all are feeling fine. In this situation, we have been struggling a lot with the learning process. So, to overcome this situation, here I am to help you learn Discrete mathematics, that is CSE230. Hope you all will take full advantage of this situation or this opportunity since we all are connected now. The course title is Discrete Mathematics. What is Discrete Mathematics? Discrete maths is the study of mathematical structures that are countable, separable, and distinct. Unlike calculus or geometry, discrete maths deals with non-continuous integral data or numbers or graphs or logical statements. In this course, we will be focusing on a few topics, and those topics are set theory, function, combinatorics, probability, induction, recursion, propositional logic, Pigeonhole principle, modular arithmetic, etc. Since this is our first class, we will be studying a comparatively easier and known topic to all, that is set theory. Yes, we have studied set theory in all previous classes, yet we will be learning the basic concepts of set theory throughout this semester. So, in the segment 1, we will be studying application of set theory in computer science, definition of set theory, methods of expression of sets, roster or tabular format, set builder format, intervals, closed and open intervals, and we will see some examples. So what are the applications of set theory? Right here, application of set theory in computer science. Set theory is widely used in computer science and it is the central part of underlying mathematical language. In data structure, it deals with efficient implementation of set operations, and in database theory, it also deals with relational database as relation over sets. Besides, in programming language semantics, computability theory, and study of logic, axiomatic set theory is widely used. So, we know that set theory is very important in computer science. What is a set? The definition of set. Set is the collection of unordered different elements or objects. This collection may be of some objects like musical instruments, or some numbers, real, natural, or integral, whatever it is, or some colors, and we have to remember that the order of the elements in a set doesn't matter. So, how do we express a set? We denote a set by a capital letter, say capital A, and there are two different methods of expression of a set. And what are those? Roster or tabular format. And in roster format, we express a set like this. We start with a curly brace, then we write down the elements, separate them using comma, and close it by another curly brace. This is how we express a set in roster or tabular format. So, there are some frequently referred sets, and we will be having those sets throughout the semester encountered, and those sets are capital N, capital R, capital Z, Q. This refers to, capital N refers to the set of natural numbers or all positive integers. This set refers to all real numbers. It can be rational, irrational, integral, or fractional. Z refers to the set of all integral numbers. It can be negative or positive. And Q refers to the set of rational, all rational numbers. So these are some frequently referred sets. Now, how do we express a set using set builder format? We have already seen a set being expressed in tabular format. can we express this set in set builder format? Yes, we can. For expressing a set in set builder format, we'll start with a curly brace and then we'll pick the representative element of this set, say x, and x belongs to n. Why have I written that? Because see, all of those elements of set A are natural numbers. So this sign refers to belongs to, that means x is the common element of set A and it will always be a natural number, and x will be less or equals to 4 and greater or equals to 1. Let's see if from this expression we can determine set A. First, x belongs to n, means x is a natural number and x is always less or equals to 4 and greater or equals to 1. So there are 4 numbers, 1, 2, 3 and 4, which actually satisfy this condition, like 1 is less or equals to 4 or less or equals to x is less or equals to 4 and greater or equals to 1 and x belongs to n. So to express a set in set builder format, we'll have to pick a representative element and we'll have to describe the basic feature of x so that we can determine all of the elements of set A. Let's see another example. Set B is a set which contains some elements which are power of 2. So can we express set B in set builder format? Yes. At first we see all of the elements of set B are natural numbers. So x belongs to n such that x has a form of 2 to the power k, right? All of the elements are some powers of 2. So x equals to 2 to the power k, where k is the power and all of the k's are natural numbers. So k belongs to n, and what is the limit of k? K is greater or equals to 1 and less or equals to 5. So from this expression we can figure out what could possibly be the elements of set B. Okay. So can I ask you something? Pause this video and express this set in set builder method. This set is given in tabular format. We'll express this set in set builder method. How? Okay, try it yourself. We'll move to the next topic. So now we will know about intervals. We already have seen in our previous classes that if A and B, intervals. If A and B are two numbers where A is less than B, this is called closed interval from A to B. This refers to a set of real numbers where x belongs to R. That means x is a real number and x is less or equals to B and greater or equals to A. So this set, closed interval from A to B, contains all of the real numbers between A and B, including A and B. Okay? Now, if we write it this way using first bracket, we call it open interval from A to B, and this refers to a set where x belongs to R, A is less than x, and x is less than B. So this set refers to the set of all real elements or all real numbers that are greater than A and less than B. See, here x can have a value of A or B, but here x cannot be equal to A or x cannot be equal to B. But all of the elements between A and B. Okay, now we know what are closed intervals and open intervals. Now we will see another example where we can figure out if this set can be expressed in set builder method by us. X belongs to R such that x is greater or equals to 1, less or equals to 2. Let's check if it is correct. No, many of you have already understood this is not the right expression, because here we used closed interval and here we used open interval. So x can have or possess the value of 1, but it cannot be equal to 2. So the right expression of this set in set builder method will be x belongs to R such that 1 is less or equals to x less than 2. So 1.5 or 1.7, anything, all of these numbers will belong to this set. Our first segment is over. Thank you. We have learned about closed and open intervals. As we know, open and closed intervals refer to some set of real numbers. Here, at first, we can see a closed interval from 3 to 5. This is a set where all of the elements of this set will be real numbers and they must have a value between 5 and 3, and they can be also 3 or 5. So let's see if we can express this set graphically. Yes, we can. We can use here a number line. That is 0, 1, 2, 3, 4, 5. See, here the limits are 3 and 5. So we first draw two circles and then we'll see if the value of x can be less than 3. That means can be left of 3. No. Can be right to 5. No. The value of x must be between these two circles. So our solution will remain within these two circles. So we will make it bold. Then we will fill in the circles, because the value of x can also be x or 5. So this is how we express a closed interval within a number line. And let's see, here we have an open interval and closed interval here. So how do we express this in a number line? 0, 1, 3. So here x, any element of this set can be greater than 0 and it will be less or equal to 2. So we will take the limits first, and then since x can have the value of 2, so we will fill in this circle and we'll keep it void, and all of the values of x will be between 0 and 2. So we will make it darker or bold, and this region will show the set 0 to 2. This is how we can express closed and open intervals through number line. We can do another example. So say this is a set and it's an open interval. We'll draw a number line 0, 1, 2. We will pick the limits. Since this is open interval, x cannot be equal to 1 or equal to 2, and x will have all values between these two circles. So we will make it bold, and this portion will express the set open interval from 1 to 2. Thank you.